Let's get it on.
You don't give a what, we don't give a what. Get it on the floor, get it on the floor. Get it on the floor, get it on the floor. You don't wanna party, then your ass gotta go. You don't wanna party, then your ass gotta go. And you can ride to this motherfucker, bounce to this motherfucker.
Hi, my name is Usher Delafati, and this is my sidekick, Kinetic.
What's up, guys?
And we are doing the physics of skateboarding. We want to show you another aspect of physics. Yeah.
We see physics everywhere in our lives.
All around us.
When we're walking, when we're jumping, you know? And today, we want to show you another place where physics is. And that's skateboarding. Let me try again.
We're doing the physics of skateboarding.
The coefficient of static friction between the foot and the ground is great enough that they do not slip. The horizontal component of the force provided by the leg pushing is equal and opposite to the force of friction.
Whenever you're ready.
In the pickup, a force up on the board is evolved through rotational motion. The skater applies a torque on the tail of the board, which is stopped by the ground. The front of the board continues to rotate upwards into the skater's hand.
Oh shit!
Yeah, you can do that over. Yeah, that's good.
Alright, now I have to do it over your chest though.
The rider starts out with the center of mass over the rear wheels, which act as a pivot. The length of the board from the pivot to the end acts as a moment arm. By applying a force as far from the pivot point as possible, torque is maximized, allowing rotational motion to occur about the rear wheels. Recall that torque equals inertia times angular acceleration. The rotational motion is stopped by two factors: the ground, allowing the board to move towards at a tangent to the stopping angle, and the front foot, which pushes down on the front of the board to level it out. The tail is angled upwards to allow more time to accelerate the board, allowing it to go even higher.
Skater starts out translating in the positive x direction. By raising his arms, he reduces his weight mg for a brief period of time. He is allowed to rotate the board about its center of mass. To stop the rotation at 90 degrees, the skater swings his arms in the opposite direction. Now the skater is translating forward again. However, the frictional force is increased due to the wheels experiencing kinetic friction instead of static friction, because they're not rolling anymore. The frictional force eventually slows the board to a stop.
Please God, someone do this. Alright.
In shove it, the same force is applied as in the ollie to get the board airborne. Then a force is applied by the rear foot in the XZ plane that acts at an angle theta to the radius of the board. This produces a torque and also an angular acceleration that rotates the board about the y-axis. The torque produced rotates about the center of mass, and then the board descends back to the ground due to the force of gravity. On the kickflip, the same force is applied as on the ollie to get the board into an airborne inclined position. The front foot applies a force in a downward angle that is theta to the radius of the board. This produces a torque which also produces an angular acceleration of the board. This angular acceleration rotates about the x-axis. Then the board descends back to the ground due to the force of gravity like in the ollie.
You guys would ever do it.
Like, okay,
This is just a highlight reel.
see, what we need is like, coming from above and you can see the board rotate 180 degrees. You know what I mean?
On the varial flip, the same force is applied as in the ollie to get the board airborne. Then a force is applied by the front foot in a downward position that acts at an angle theta to the radius of the board. This produces a torque, which also produces an angular acceleration about the x-axis. At the same time, the rear foot applies a force in the xz plane, which acts at an angle theta to the board. This produces a different torque and an angular acceleration that rotates the board about the y-axis. Both of these torques occur simultaneously and rotate about the center of mass. Then the board and the person descend back to the ground due to the force of gravity, and the same forces apply as in the ollie.
I sip poison that cures when dream of rainy days, land of Midwestern shores. Just one more step, you say. So here we go. I'll pack my bags and head out to the west with a hope under my arms. So here we go. Pack my bags and head out to the west with a hope under my arm. Big skylines on the lake, reflections light our eyes. This summer's make or break, not concrete like sunrise. So here we go. I'll pack my bags and head out to the west with a hope under my